All right, let's talk about machine learning. And don't worry, we're not going to get bogged down in a bunch of complex code. Instead, we're going to pull back the curtain on this amazing way of thinking that is, believe it or not, already changing your world every single day. So let's just dive right in. Okay, so picture this. You've probably been here, right? You're browsing online, you finally find that perfect pair of shoes you've been looking for, you add them to your cart, and you check out. Just a totally normal, everyday thing. But then something kind of weird happens. The very next page you see, or maybe an email that hits your inbox just seconds later, is showing you the absolute perfect pair of socks to go with those new shoes. It feels a little spooky, doesn't it? Like, how on earth did they know? Well, I can promise you it's not magic, and it's definitely not a lucky guess. It is the power of machine learning, or ML, at work. And today we're going to figure out exactly how it does it. So to really get our heads around machine learning, first we need to understand how different it is from the way we've always instructed computers. This is a really fundamental shift in logic. And here it is, the crucial difference. On the left, that's traditional programming. Pretty simple. We give the computer the rules and the data, and it spits out the answers. But machine learning, over on the right, completely flips the script. We give the computer the data and the answers, and we ask it to figure out the rules for itself. It's kind of backward, but it's brilliant. So the textbook definition is that machine learning is a part of AI that teaches computers to learn straight from data. Images, text, numbers, so they can make decisions without a person having to write code for every single possible situation. Instead of us coding the logic, we let the machine learn the logic. But of course, it's not a perfect science. There are some big challenges. One is something called overfitting. This is when a model doesn't actually learn, it just memorizes. Imagine trying to teach it to spot dogs, but you only show it pictures of golden retrievers sitting on grass. It might just learn to recognize grass, not the dog. Then there's the black box problem. Sometimes a model gets so complicated that we know what we put in and we know what we came out, but we have absolutely no idea how it got from point A to point B. And finally, data bias is exactly what it sounds like. If your training data is biased, your model's predictions are going to be biased too. Garbage in, garbage out. So how do these machines actually do the learning? Well, it turns out there isn't just one single way. There are actually three core philosophies, or paths, that a machine can take to figure out the rules of the world. And this diagram lays it out perfectly for us. We've got supervised, unsupervised, and reinforcement learning. You can think of them as three different styles of thinking. One is like learning with an answer key, another is about discovering patterns all on your own, and the third is learning through trial and error. Let's break each one down. First up, we've got supervised learning. And honestly, the best way to think about this is like a student who's studying for a test and they have the complete answer key. They've got the questions, they've got the correct answers, and their whole job is to figure out the relationship between them. Now, this student really has two main jobs. The first is called regression. This is all about predicting a number, something on a continuous scale, like what's a house going to be worth next year, or what's the temperature going to be tomorrow. The second job is classification, and that's all about putting something into a bucket. Is this email spam, or is it not spam? Is this a picture of a cat or a dog? Now, the foundation for all regression is this idea of correlation. It's just a fancy word for how two things are related. You can see here a perfect positive correlation means when one thing goes up, the other goes up with it. And a negative one means they move in opposite directions. Think about the age of a car and its price. The older it gets, the less it's worth. Regression models are basically hunting for these relationships to draw a line of best fit that they can then use to make new predictions. On the other hand, classification is way easier to picture. At its core, it's just a sorting task. It's exactly like when you sort your recycling into the correct bins. This goes in paper, that goes in plastic, this one's metal. A classification algorithm does the exact same thing, just with data. And one of the most intuitive ways to do this is with an algorithm called K-nearest neighbors, or KNN. The logic behind it is just so human. It's based on that old saying, you are who you hang out with. So when a new unknown piece of data shows up, the algorithm just looks at its K closest neighbors, and if most of its neighbors are, say, in category A, then it gets labeled as category A. It's that simple, but it's incredibly powerful. Okay, so that's all fine and good if you have an answer key. But what if you don't? Well, that brings us to unsupervised learning. For this one, think of the machine as an explorer, dropped into a brand new land with no map and no guide.
The goal isn't to get to a specific place, it's just to discover the hidden patterns of the land itself.
So the number one job for our explorer is something called clustering. The whole goal is to just group similar things together, automatically. Imagine someone gives you a giant, mixed-up pile of fruit. You've never been told what an apple or a banana is, but you can pretty quickly start making piles based on color or shape or size. You'd be finding the natural categories all on your own. A really popular algorithm for this is K-means clustering. So let's just walk through it. Step 1, you decide how many clusters, or K, you're looking for. Step 2, the algorithm just drops K random starting points onto the data. We call these centroids. Step 3, every single data point gets assigned to whichever centroid it's closest to. Now here's the clever part. Step 4, the algorithm finds the new center of gravity for each of those clusters and moves the centroid right to that spot. And then it just does it again and again, repeating steps 3 and 4 until the centroids stop moving and the groups are nice and stable. And the patterns this can uncover are sometimes totally unexpected. There's this famous story about a retail company that used clustering and found a small but incredibly profitable group of customers they had no idea even existed. It turned out these people almost exclusively shopped on their website at 2 o'clock in the morning. That one little insight, discovered by the machine, totally changed their whole late-night marketing strategy. All right, that brings us to our third and final style of thinking, reinforcement learning. This is the player. It doesn't learn from a big data set, it learns by doing. It's a lot like learning to play a video game through nothing but pure trial, error, and rewards. So here's the basic setup. You have an agent, that's our algorithm, and it's operating inside an environment, like a game or a simulation. The agent takes actions, and for every single action, the environment gives it either a reward or a penalty. A good move gets a point, a bad one loses a point. And after millions and millions of tries, it just naturally learns the sequence of moves that racks up the highest possible score. And don't think this is just for simple games. No way. Reinforcement learning is the exact technology that powered Google's AlphaGo. It taught itself how to play the ancient game of Go simply by playing against itself millions and millions of times. It eventually got so good that it beat the world's best human player at a game that has more possible moves than there are atoms in the known universe. I mean, that is the staggering power of learning from consequences. So, where's all this headed? We've just looked at 3 fundamentally different ways that a machine can learn, perceive the world, and ultimately make decisions. So, just to recap, we've got our 3 different ways a machine can think. There's the student, who learns from an answer key. There's the explorer, who finds hidden patterns all on its own. And there's the player, who learns from the consequences of its actions. From recommending socks to mastering unbelievably complex games, these methods aren't just tools. They're entirely new ways of creating knowledge. And that kind of leaves us with one final big thought to chew on. As these systems get better and better at finding patterns that we can't see, what does that mean for things like human intuition and creativity? Will the next great scientific breakthrough, the next discovery that changes the world, will it come from a human mind, a machine, or maybe a partnership between the two?